All right, gametogenesis. Okay, this is just another word that we can use for meiosis. Meiosis is referring to the production of the gametes, or the production of the sex cells. Okay, so gametogenesis. We move into specific names for meiosis, spermatogenesis, and oogenesis. So again, we said there are two kinds that exist, and again we said spermatogenesis, which specifically would produce the sperm, oogenesis, which would specifically produce the secondary oocyte once fertilized, the egg. Okay, so where are these events taking place? Let's first start out with talking about the male and spermatogenesis. Spermatogenesis takes place in what we call the seminiferous tubules of the testes, and it occurs in the seminiferous tubules of the testes. Now, the testes are referred to as the male gonads. So I know that you can go ahead and guess what we're calling the female gonads. Absolutely. If you said the ovaries, that is absolutely correct. Now, in order for men to be fertile and to produce the most, amount of sperm that's possible, then the testes must remain cool. So the testes are then housed in a thin-walled pouch of skin that we call the scrotum. Okay? Now, the other way for helping the testes to remain cool, because we know that the scrotal sac is outside of the body. Well, they also have another, I guess you could say, feature of their physiology called the peniform venous plexus, which is also responsible for helping to cool the blood as that warm blood enters the testes from the body. And the peniform venous plexus picks up the heat so that those cells are not damaged, okay, by the hot blood that's moving in, because we said anything above 96 degrees is going to cause us temporary sterility. So we want to make sure that men are wearing the right type of clothing and not taking very long hot baths or long dips in the hot tubs, okay? Because we said above 96 degrees slows or dramatically stops sperm production. So we said things that may result in temporary sterility are wearing tighty whities, wearing tight pants or tight jeans. So a lot of the commercials that you see now, they're telling men to wear briefs, okay? So we said taking these hot baths as well. Now, the process, remember we said was, let me see, can I find an eraser and get this stuff off of the screen? Yes, thanks. But the process we said was taking place within the seminiferous tubules of the testes. So let's grab a different color pen and draw. So here's a seminiferous tubule. Can't draw too good. Here's a seminiferous tubule. Okay, so each one of these is a seminiferous tubule. Okay, this is what we want to refer to as the lumen of the tubule. So any immature sperm cells, this is where they're going to begin their travel to the epididymis for further maturation. our spermatogenic cells. We know that these are the guys that are on the outermost edge, okay, located here around the edges, okay, of each of the tubules. We're going to talk about it in a minute. We're going to mention these cells that are actually in between the tubules. So let's get another pen. Well, I'll just do that in a minute. But anyway, okay. So between the two testes, we're going to find several hundred tubules between the two. If we stretch those tubules out in length, we're going to end up with about 1/4 of a mile of sperm-producing tubules, okay, because each of those tubules is about 1 to 3 feet in length. So again, that's going to give us about 1/4 of a mile of sperm-producing tubules. Now, you notice that you see an arrow. It says that we have some cells that are in between these cells, and those cells that are in between the tubules, we want to refer to those cells as the cells of Leydig. We also refer to them as the interstitial cells. These cells that are in between the tubules, these guys are going to be responsible for producing testosterone. So we said these guys, all the ones that are in between these tubules, okay, it says these are going to be responsible for producing testosterone. All right. So, again, the interstitial cells are also referred to as what? The cells of Leydig. Okay? What do? They make testosterone. Okay? They make testosterone. All right. So, it says, well, how is the process of spermatogenesis taking place? Well, it occurs from the outermost towards that lumen that I drew for you a minute ago. So here's our spermatogenic cells again. Okay, so we're going from the outermost, and then we're going to make our way towards the lumen. Okay, so the most immature cells are going to be here. The most mature cells are going to be towards that lumen. All right, so one of the other types of cell which is going to be responsible for supporting the process, in addition to supporting the process, providing support, protecting them through a blood-testis barrier, and also allowing nutrients to diffuse to these developing cells. They are called the Sertoli cells. The other name for the Sertoli cells are also the sustentacular cells. The Sertoli cells are also called the sustentacular cells. The sustentacular cells are also the Sertoli cells. It's just another name for the Sertoli cell. Okay? Now, these cells, again, they also provide what's called a blood, or create a blood testes barrier. I'm writing with the mouse, so this is not so good. So they provide a blood testes barrier. O-O-I-E-R. Okay? So we want to make sure that these developing cells are protected, and that no blood actually comes in contact with them, because the immune system will try to destroy them. So they create a blood testes barrier, again, allowing nutrition to get to the developing sperm cells without being exposed to antibodies. All right, now, the outermost layer of cells, or our spermatogenic cells, are referred to as spermatogonia. The spermatogonia are those cells that we saw in the last slide that are located next to the basement membrane. Generally, these are we know that these are your normal 2N or diploid cells. The spermatogonia always make a copy of themselves, and one stays next to the basement membrane. So men can produce an almost unlimited amount of sperm because these cells are capable of undergoing mitosis as well as meiosis. Again, they are capable of undergoing mitosis as well as meiosis. So we can produce this unlimited amount of sperm. So again, one of the copies will stay next to the basement membrane. The other one moves in and becomes the primary spermatocyte. Okay? So the other one goes in, and this is the one that will undergo meiosis, and it becomes a primary spermatocyte. So remember, again, we make a copy. You have an A copy that stays next to the basement membrane. The B copy moves in and becomes a primary spermatocyte. This is the one that will undergo meiosis. So the primary spermatocytes, easily recognizable because they are usually the most prominent cells that you're going to see inside of the seminiferous tubule. So these big guys, so if you look over here in this real cell, one over there too, these guys, okay, that row that I've outlined in blue, those are going to be your primary spermatocytes. These guys that I'm going to outline in, well, actually, I'm not even going to outline. I'm just going to go ahead and stick with the same color. These guys, again, that are on the outermost edge that I'm pointing at, these are your spermatogonia. Okay, now, because they are getting ready to they're undergoing meiosis, it says these have diploid replicated chromosomes. So we've gone through interphase. We've doubled the cytoplasm. We've got these replicated chromosomes. Chromosomes are condensing. Okay, so you see these dark regions getting ready to go start forming in the nucleus. We know we haven't moved directly into prophase yet. Why? Because we know that this nucleolus is going to disappear. So we're in interphase, and we have the diploid replicated chromosomes. So once this undergoes meiosis number 1, this is what's going to produce our secondary spermatocytes when it divides in telophase number 1. And we'll end up with 2 secondary. So the 2 and the prime sign means secondary, so 2. So we'll have 2 of those secondary spermatocytes. Okay, at this point we still have, we've just separated the homologous chromosome pairs, and then we'll separate them again, and they'll separate at the centromere in meiosis number 2. Okay, so they'll divide again in meiosis 2, and we'll end up with 4 haploid spermatids. Now, this arrow is misplaced. Here's a spermatid. Okay, so here's one where you can see they're actually undergoing the rearrangement to form a sperm. But anyway, because the spermatid is going to be circular until he undergoes that spermiogenesis process. Okay, so it says at this point we have 2 secondary spermatocytes that will divide in telophase 2 to produce 4 haploid spermatids. Okay, and then meiosis is not, I guess it's complete, but not fully complete because we don't have functional sperm, so they will undergo a process that's called spermiogenesis, which would allow for the rearrangement of the cytoplasm and a formation of a flagella in order to provide us with some functional sperm. So they have to undergo spermiogenesis again. That's a maturation process that will rearrange the cytoplasm as well as form a flagella. All right, and we will stop right there.